Hey everyone, and welcome to this explainer. I'm so glad you're joining us today because honestly, we're looking at something that feels, well, a little bit like kitchen magic, but actually, it's just a really clever use of physical mechanics. We're talking about kitchen gadgets that perform these radical physical transformations on the foods we eat every single day. So let's just dive right in. We usually think of cooking as a thermal thing, right? Like applying heat to turn something raw into something cooked. But what about mechanical transformations, using pressure, time, and gravity to completely rewrite a food's texture and structure? That is exactly what we're going to unpack today.
To kick things off, I've got to ask you a question. How in the world do you turn flowing, liquid yogurt into a solid, sliceable block of culinary gold? Seriously, think about that for a second. We're starting with your standard, everyday liquid ingredient, the kind of stuff you'd pour over your morning granola, or even just drink straight out of a glass. It's fluid, it's got high volume, and it totally conforms to whatever container you pour it into. But we want to turn it into something completely new, something with real structure, something you can actually plate. So how do we bridge that gap without cheating and adding a bunch of chemical thickeners or gelatin?
Well, we've got something that brilliantly illustrates the answer. We're going to look at a complete, four-step visual guide to this exact transformation, all happening thanks to this one really fascinating device. Today, we're basically playing culinary detectives. We're going to carefully unpack this photographic evidence, going step by step, panel by panel, just to figure out exactly how this rapid change goes down. It's an incredibly simple process on the surface, but as we break it down, you're going to see just how elegantly this tool is designed to basically hack the physical properties of our food.
Right off the bat, there's a specific term printed on the gadget's label that we need to talk about: mizukiri. This gives us the foundational context for the mechanical process we're looking at. Mizukiri is a Japanese term, and it basically translates to water cutting. Or, in more practical terms, it's the method of rapidly draining or straining liquid out of foods. Now, traditionally, you might do this by wrapping up some tofu or yogurt in a cheesecloth, hanging it over your kitchen sink, and just letting it sit there for 24 hours while gravity does the slow, tedious work. But let's be real here. When you're craving a thick, creamy yogurt spread, you usually want it today, not tomorrow. So, as the label Quick Mizukiri promises, we are looking at a thoroughly modern, highly engineered shortcut.
Okay, so how does this shortcut actually work? It all comes down to the hardware. Before we see this thing in action, let's break down its anatomy. It's basically a clever system of multi-layered nesting containers. First up, you've got this clear outer catchment tub. Think of this as the reservoir. It's there to catch all the expelled liquid or the whey. Then, sitting inside of that, is a blue inner straining basket, which is lined with a superfine mesh. Next up is a totally separate flat white pressing disc. And finally, the actual engine of the whole operation, a blue locking lid that's packing a seriously heavy-gauge metal spring. Every single one of these pieces has a very specific, vital role to play in the physics of this whole transformation.
All right, let's see this thing in action and watch how it all builds, starting with the initial pour. Check out the consistency of the liquid coming out of that white jug. It's your standard thin flowing yogurt. The user is pouring it straight into that blue inner straining basket we just talked about. Now at this stage, that yogurt is mostly just water. If you walked away and left it like this, sure, some of that liquid might slowly drip out the bottom, kind of like a normal strainer. But remember, the whole point here is a quick transformation. We can't just wait around. We need to introduce an active force.
And that brings us to our next major intervention. The user takes that white pressing disc and places it directly on top of the freshly poured yogurt. Notice how perfectly it's sized? It fits tightly inside the walls of that blue strainer. And guys, this isn't just a lid. It is a mechanical plate. Its sole job is to create a perfectly even, flat surface across the entire top layer of the liquid. Because think about it. Without this disc, if we just applied pressure directly from above, it would punch a giant hole right through the center of that soft yogurt. Messy, right? This white disc guarantees that the force we're about to apply gets distributed evenly across the entire surface area.
Now for the really fun part, the engine of the whole operation. The user brings in that blue locking lid, but look closely right underneath it. You see that heavy, coiled metal spring? As they push the lid down and twist it to lock it onto the clear outer tub, that massive spring gets compressed right against our white disc. This right here is the ultimate solution. We are completely done relying on passive gravity. We've just introduced active, continuous spring-loaded pressure. That spring is going to relentlessly push down on the white disc, practically forcing the liquid out through the mesh basket and down into the clear tub below. It is active extraction at its finest.
So just to quickly recap this kinetic action. Step 1, you pour in the flowing yogurt. Step 2, you drop in that flat pressing disc. Step 3, lock down the spring-loaded lid to kick off that continuous pressure. And finally, Step 4, you unmold your newly compressed block. It is just a highly satisfying, super intuitive sequence of mechanical actions.
I really want to emphasize the absolute stark contrast between these two physical states, because it's pretty wild. Before we start, the liquid is high volume, it's flowing, it splashes everywhere. It is fundamentally unsliceable, right? But after that spring-loaded pressure does its thing over time, the after state is like looking at a totally different food. It's solid. It's lost a massive amount of its original volume because all that excess water has been forcefully pressed out into the catchment tub. It's incredibly compressed. And maybe most interestingly, it's completely molded. It's now holding its own shape without a container holding it together.
And that leads us to the big payoff, the final reveal. The user takes that blue straining basket, inverts it right onto a plate, and just look at what comes out. It's this firm, completely standalone block. But wait, look a little closer at the top of the block itself. You can actually see these radial pie slice indentations molded directly into the surface of the food. Those perfectly match the structural support ridges that are built into the bottom of the blue strainer. So the yogurt was pressed so firmly, with so much consistent force, that it literally took on the exact architectural impression of its container. How cool is that?
But hey, put on your detective hats for one more second and look past the yogurt. Check out the contextual clues hiding in the background. Throughout the whole process, you might have noticed a clear glass bowl filled with these bright red cherry tomatoes just sitting there. Well, why are they there? In the world of food styling, absolutely nothing is an accident. Those cherry tomatoes are implying a very specific culinary direction. They're telling us that this newly solid compressed yogurt, which, by the way, now basically has the texture of a soft cheese, kind of like a labna or a fresh mozzarella, is destined for savory dishes. We're not just looking at a sweet breakfast food anymore. It's a salad ingredient now. It's a savory spread. The mechanical transformation has entirely rewritten its culinary utility.
This simple little tool just brilliantly illustrates how a basic grasp of physics, literally just using a spring to apply continuous pressure to extract water, can completely reinvent an ingredient. We just watched a flowing liquid morph into a sliceable, savory block. It's a real game changer. So as we wrap up today's explainer, I want to leave you with a thought to chew on. If you had this gadget, this spring-loaded culinary transformer, sitting on your kitchen counter right now, what would you create? Would you go for that dense, savory yogurt cheese to pair with some cherry tomatoes, or would you start experimenting with totally different liquids? Understanding the mechanics really does open up this whole new world of culinary experimentation. Thanks so much for joining me to unpack this fascinating process and keep exploring the science in your own kitchen.